Hello everyone, and welcome to another video in my channel. In this video, I have a fine combination of exponential and linear functions making an equation. Both functions are increasing, but there is a point where the two graphs of these two functions will meet, and that point is where we'll have the value of x. I will be presenting two methods. In the first method, I am going to solve it algebraically, and then I will compare terms. I'm going to rewrite 27 raised to the power x as 3 raised to the power 3 all raised to the power x plus 3 times x is equal to 4. Then 3 raised to the power 3x plus 3 times x equals to 4. And then 4 can be written as 3 plus 1. Then 3 raised to the power 3x plus 3 times x equals to 3 plus 1. And so 3 raised to the power 3x equals to 3. That means 3x equals to 1. And so this is raised to the power 1. So we have 3x equals to 1 and x equals to 1 over 3. Let us check if this is the solution, or if this is the point where these two graphs meet. So checking, we have 27 raised to the power 1 over 3 plus 3 times 1 over 3. Is it equal to 4? Now, 27 to the power 1 over 3 is 3 raised to the power 3 times 1 over 3 plus 3 times 1 over 3 is equal to 4, because this and this will cancel out, giving us 3 to the power 1 plus this and this will cancel out, giving us 1 equals to 4. So the value of x is 1 over 3. This is the first method. Now for the second method. For the second method, we are going to use the Lambert W function method. What do we know about this method? If I have x times e to the power x equals to a constant, I can take the w of both sides. W of x times e to the power x equals to w of constant. But this, that is w of x times e to the power x, is equal to x. So we now have it as w of the constant. So all we need to do is to rewrite or manipulate this expression to be in this form, so that we can take w of both sides, then find the value of x. So let's proceed. I'm going to rewrite 27 as 3 to the power 3x plus then 3x is equal to 4. Then I will let y equals to 3x. Therefore, 3 to the power y plus 3y plus y rather is equal to 4. Now I will subtract y from both sides. 3 to the power y is equal to 4 minus y. Then divide both sides by 3 to the power y. 3 to the power y over 3 to the power y equals to 4 minus y divided by 3 to the power y, which will give us 4 minus y in brackets times 3 to the power minus y. So this is 1 equal to 4 minus y times 3 to the power minus y. Now I want to make this term to be equal to the power here. So to do that, I will multiply both sides by 3 to the power 4. So 3 to the power 4 times 1 is equal to 4 minus y times 3 to the power minus y times 3 to the power 4. Now if I apply the addition law of indices, which is a raised to the power b times a raised to the power c, I will have a raised to the power b plus c. This property will be applied here. So 3 to the power 4 is equal to 4 minus y, then times 3 to the power minus y plus 4. I can rewrite it as 4 minus y times 3 to the power 4 minus y. Now having done this, I now need to rewrite this term. If I have e to power ln x, it is the same thing as x. Therefore, e to power ln 3 to power 4 minus y is the same thing as 3 to power 4 minus y. Good, so I will now replace this with this. That becomes 3 to power 4 is equal to 4 minus y times e to power ln 3 to power 4 minus y, which is the same thing as 4 minus y times e to power 4 minus y ln 3. Beautiful. Now let me go up. So we can see the only term remaining for this to be equal to this is the ln 3. We will now multiply both sides by ln 3. So I have 3 to power 4 times ln 3 is equal to 4 minus y times ln 3 times e to power 4 minus y ln 3. So this is equal to the power of the exponent. I can rewrite the expression on the left hand side so as to be of this same form. So we have 3 to power 4 times ln 3 will now be equal to 3 to power 3 plus 1, then ln 3. So we have 3 to power 3 times 3 to power 1 times ln 3. Now we'll take this as the power. That becomes 3 to power 3 times ln 3 to power 3. Now let us also rewrite this one. Let us remember that e to power ln x is also x. Therefore, e to power ln 3 to power 3 is this, times ln 3 to power 3. So which is 3 ln 3 times e to power 3 ln 3. So we'll now equate this term to the right hand side. That becomes 3 ln 3 times e to power 3 ln 3 is equal to 4 minus y ln 3 times e to power 4 minus y ln 3. So both in the left hand side and in the right hand side we have these being equal to this. As we have these being equal to this, we can now take the w of both sides. So w of 3 ln 3 times e to power 3 ln 3 equals to w of bracket 4 minus y ln 3 times e 4 minus y ln 3. Now let us remember that if we have w of e times e to power x, it is the same thing as x. So this expression simplifies into this. That becomes 3 ln 3, and this expression also simplifies into this, 4 minus y ln 3. This and this will cancel out. So 3 is equal to 4 minus y, and so y is equal to 4 minus 3. Therefore y is equal to 1. Let's recall that y is equal to 3 to power x, not power x please. Y equals to 3 times x, and so 1 is equal to 3 times x because y is equal to 1 and x equals to 1 over 3, just as we have it in the first case. If you like this video, I would like you to give it a thumbs up and also subscribe to my channel if you haven't done so. There are many other interesting videos in this channel that you can check out. I will appreciate it if you check them out. Thanks for watching and see you in another video. Bye.